final question in these last 22 seconds.
Go for it.
If Genesis were actually historical in the way that I've been describing, how would you have expected God to say it? If evolution didn't happen, how would you have expected God to say it in the book of Genesis? Why is there no hint of evolution in the Bible?
Why is there no hint of quantum mechanics in the Bible? That's not what we're talking about.
Because evolution is a worldview, quantum mechanics is a
evolution is a theory.
Fallible idea. It's a theory, it's not a fact.
It's a theory, yeah. You need to look up how theories are used in science.
Thank you.
You serious?
The word theory has its origins in the Greek word theoria, which is translated as looking at, viewing, or beholding. Greek philosopher Pythagoras, while championing the idea of subduing emotions and bodily desires to help the intellect function, changed the word to mean a passionate, sympathetic contemplation of mathematical knowledge. He considered this intellectual pursuit the way to reach the highest plane of existence. Aristotle, however, contrasted the term with practice. While both practice and theory involve thinking, the goals are different. Theoretical ideas consider things humans do not move or change, such as nature. On the other hand, practice involves thinking with an aim to desired actions. Thus, theories are analytical tools for understanding, explaining, and making predictions about a given subject matter. At no point in antiquity, however, was a theory just a mere assumption or guess. A scientific theory has 3 specific requirements. 1. It must be derived from observed evidence. As a theory is a model for understanding observed phenomena, it only makes sense that there are observed phenomena to explain. 2. It must explain the observed evidence. This is what separates a theory from a law or a fact. Facts and laws are certainly observed phenomena, but that is all they are. A theory is designed to explain why or how the phenomena occur. 3, and most importantly, it must be able to predict future evidence. This is where the word assumption comes up. An assumption is how a hypothesis is formed and a prediction is made. The process goes like this. If we assume theory A to be true, we should expect result B when we perform experiment or observation C. So, for example, we could define theory A as, the presence of the teacher in the classroom affects the noise level in the room. A hypothesis would then be, if we assume that the presence of the teacher in the classroom affects the noise level in the room, we should expect to see the noise level of the classroom to increase when the teacher leaves the room. The increase would be the expected result, and the absence of the teacher would be the experiment. If we do see an increase in the noise level after the teacher leaves, we can say that the theory has support, but it cannot be said to be proven. A theory is never proven. It is only tested and supported. There could be other factors causing a change in noise level. For this reason, there is one more requirement for a scientific prediction: falsifiability. Scientific tests are actually designed with the possibility of disproving the theory as well. For this, we need what is called a null hypothesis, which states the condition that would disprove the theory. In this example, the null hypothesis is, if we don't see an increase in noise level in the classroom when the teacher leaves, then we know that the assumption that the teacher's presence affects noise level is wrong, and we must either reject our theory or revise it. It is also assumed that a theory must be wrong to some degree, but using these premises, the strength of a theory is evaluated by its ability to explain the evidence and predict the evidence. On July